In this video, we're going to take a look at the distance formula, how it is derived, and how it is applied. First, choose any 2 points you want. Call them A and B. They could be off over here out in space somewhere. And I need to find the distance between those points. Well, the distance is always measured along a straight line, if I could actually draw one. But I have no way of figuring that out. So what I do is, if you can imagine it, is I lift it up and I pull it over here and I line it up on a grid and I pull it in until it's good and tight. Once it's there, I drop a vertical line down to the origin and a horizontal line over to the origin. This forms a right triangle. Now, how do I determine the distance? Most of us would actually count, but officially in elementary school, we learned that to find the distance, I would say 8 minus 0, which would give me the distance being 8. Then I would do the same here. I would say 6 minus 0 to get my 6. Okay. Then I would use the Pythagorean theorem that says 6 squared plus 8 squared equals the distance AB that I'm looking for squared. Okay? And so I would actually square those out, but I'm not going to. Well, yeah, I am. So that'd be 36 and 64. And that would give me 100. But I don't want to know what the distance squared is, so I would take only the principal square root because I can't have a negative distance. And that would be my distance. Now, the problem is I don't want to have to do that every time I'm looking for a distance. So after doing it a whole bunch of times, I start figuring out, you know what, I'm doing the same thing every time. So what I would start learning to do is this. I can't always put it here. Sometimes I'm given some that are everywhere else, but take a look at what I'm doing. I'm subtracting the y values and then I'm squaring that to get one of the legs in my Pythagorean theorem. I'm doing the same with x2 minus x1. I'm subtracting the x values and squaring that to get the other leg in my Pythagorean theorem, and that gives me the hypotenuse squared. And then at the end, I have to take the square root. Okay, well, what that leads to is this. The distance between any 2 points in the rectangular coordinate system, not just those that I can arrange to be on my axes, works exactly the same way. I find the difference in the x value squared. That's one leg of my right triangle. The difference in the y values squared, that's the second leg in my right triangle, equals my distance squared. But I don't want distance squared, so I take the square root. So this distance formula is really just an application of the Pythagorean theorem. But the benefit of having a distance formula is that I no longer have to put things in the coordinate plane and drop vertical and horizontal lines to try to figure it out, because now I have a formula. So I can just say the distance is a square root, and I'll save the top for a minute, of the difference in the x's squared plus the difference in the y's squared. So there's my distance formula, and all I have to do now is simplify. So negative 1 minus 2, that's negative 3. That got squared. Negative 3 minus 3 is negative 6. That's going to get squared. By the way, a little note here. If you did this is 0.2 and this is 0.1, you've pretty much got the same thing I've got, except you've got a positive 3 and a positive 6. But on this next line, when we actually square them, we're both going to get 9 plus 36. So it doesn't matter the order, which one's 0.1, which one's 0.2. Don't waste time trying to figure that out. Now, This gives me the square root of 45, and I know I stated the directions one way, but I also want to go over another way. If this is a practical application, you cannot measure a square root of 45. So I would want to take the square root of 45 and round it to a couple of decimal places. So let me get a calculator here and type it in. The square root of 45 is 6.71 to 2 decimal places. It's actually 708, so 6.71. This would be what I would try to measure out, okay? However, if this is a college algebra class and we don't allow the calculator, then what we're going to want is an exact answer. And if you'll remember, you break 45 down into 9 times 5. Again, 15 and 3 do me no good because neither of them are square numbers. But 9 is, so 9 times 5, and that would be 3 square roots of 5. So the difference in the two answers is this. 3 square roots of 5 is what we call exact. Okay? This is an approximation, rounded, in this case, to 2 decimal places.